Really, it's a huge pleasure for me today to introduce Dr. Rory Cooper, who is a member of the inaugural class of the AAAS-Lemelson Invention Ambassadors Program. Dr. Cooper is a leading expert in the development of assistive technology for people with disabilities. Rory is an accomplished inventor who knows the power of invention as he sees the positive impact of his own inventions, touching people out in the community. He's been instrumental in designing new wheelchair design functions, such as the square cross-section of brace. I don't know what that is, but you're going to probably explain it to us. And the push rim activated power assist wheelchair. He's been honored by many, including the U.S. Department of Veterans Affairs, the U.S. Army War College, the AAAS, the NIH, and the International Paralympic Committee, among others. And also, he's been honored for his commitment to student mentorship and teaching, which I think is so important in terms of ensuring the next generation. So Rory is currently the FISA PVA Endowed Chair and a Distinguished Professor of the Department of Rehabilitation Science and Technology, School of Health and Rehabilitation Sciences at the University of Pittsburgh, as well as head of the Center of Excellence for Wheelchair and Related Technology at the VA Rehabilitation Research and Development Center. He has a number of additional departmental affiliations because he crosses all boundaries as far as I can see, and also is on the faculty at Carnegie Mellon University. So I welcome Rory to tell us about his work and how he thinks about invention changing the world.
So obviously I'm in a wheelchair, and that's really kind of what motivated me to do invention and get into this environment. So I'll give you a little bit of historical perspective of where I'm coming from. I was a young sergeant in the Army when I was injured due to a bicycle and a motor vehicle accident. I literally was hit by a truck, and hopefully I don't look as such, except for the wheelchair. And I was active as a runner, as you can see in those in the picture there. That's actually a little picture of me when I was Soldier of the Year for my unit, and another picture of me when I was running in a 10K race. And that other picture below that is me training for the Paralympics. And I included these two newspaper articles because I want to tell you a little story about them. So the first article, Cooper has his life back on track, is kind of clever. That was actually published in the San Luis Obispo Telegram Tribune, for those of you who are local here, and back in about 1982. And that's me doing my first marathon in a wheelchair. The gentleman in front of me is Tim Davis, who was one of my early mentors. Tim was a Marine injured in the Tet Offensive in Vietnam. I also like to say that this picture was taken about the halfway mark. I actually won the marathon. What's also interesting, if you see that the wheelchair at the time that I was given was like that you see in hospitals today, sort of the big chrome 80-pound wheelchair. You can see I'm not a terribly big guy, and when I came out of the hospital I weighed about 105 pounds, and I had to try to figure out how to get that into the sporty Volkswagen Scirocco that I bought to get back and forth to college. And so that was my first, and I thought, well, I'm going to go to Cal Poly, so I started pushing about a mile a day, and that chair lasted about 6 weeks. Now, I was lucky that my parents had an automotive machine shop, so I had access to a lathe and mill and some welding equipment, and started building my own chair. And so all of those chairs you see in the pictures, my chair, Tim's chair, those are all chairs that I was building to learn to do wheelchair racing. If you look closely at Tim's chair, it looks a lot like my chair today. And if you see that's essentially what we were trying to do for racing is a lot of what we use now in everyday chairs. So instead of having an 80-pound big folding chrome chair, you have a very tight-fitting, high-tech chair. The other story to tell you is interesting. This is the Yakitori is an article in the Engineering Times, the newspaper. Now it's an online publication directed towards engineers. I didn't know about this article until a few years ago, and it's about me. I happened to be doing a wheelchair race up in Seattle, and if you kind of look at how I'm sitting in that chair on the lower left, you can see that the wheels come right up underneath your armpits. And one of my early inventions was actually fenders for those, because you could say I'm wearing the socks, and it's not a great way to shave your underarms by having a spinning rubber tire. And so after this race, I went to a Burger King to get a baked potato and a milk, and this reporter, David Lammers, had had a fight with his wife, so he took his children to the Burger King, and he saw me and he thought I was a homeless veteran and not a college professor, although there's probably not too much difference between them in some areas. And he thought he would buy me breakfast, and so we got to talking, and I wound up buying him breakfast. We had a nice chat, and unbeknownst to me, he wrote this article about first impressions are not always the right impression, and that he didn't realize that what he originally thought I was and what I turned out to really be doing were entirely different. But what really makes the story kind of interesting is that I learned about the article about 5 years ago, because I was crossing the finish line of the Air Force Marathon, where I was taking some of our recently wounded service members, and they called out my name, and at the finish line this man ran up to me and said, are you Rory Cooper? And I said, yes. And he goes, are you an engineer? And I go, yes. He goes, can you wait here for a second? And he went back to his car, and he pulled out the article, and he said, my son was born just before this article came out. He's the one that beat you in the race. He got first, I got second, and he said that my son is studying engineering now because I pinned this article to my cubicle and told him that that he could do this, that he, from birth, I trained him to do this. So, and then he gave me the laminated article. So there was this kind of closed loop in the whole thing. So in some ways, it's sort of necessary as the mother of invention, but also you really just don't know who you're going to impact, and people that you don't even know you might have an impact on. So let me put this into context of an international grand challenge, because that was part of my task. There are about 70 million people in the world who need a wheelchair for mobility, and that's perfect. I couch that sort of carefully because most of those people don't have access to a wheelchair. Only about 20 million have access, really, which means is, and most of those 20 million are borrowing a wheelchair. So they're sharing a wheelchair with multiple people. And this is the type of wheelchair that they get, as you can see from the pictures here. This is actually a study that we did in India and Bangladesh it's a little bit old now because we got Kodak as they were getting rid of the disposable cameras you used to get at weddings to give us several thousand of those cameras. And then we handed them out to people when they were leaving, when they were getting issued wheelchairs from various camps in India and Bangladesh, and then asked us to take pictures of their home environment so we could help redesign the home environment and redesign the wheelchair for them as well. Now the worst thing is that of the 20 million wheelchairs that are out there, about 8 million of them are used in the United States or North America and Europe. So we take nearly half of the market. If you throw in Japan, Australia, New Zealand, that's actually over half of the market, which leaves the vast majority of the people in the world with no access to a wheelchair. And we only produce about 6 million wheelchairs in the world. Most of them are produced in China. Most of them are the wheelchair on the far left there, which is pretty similar to the wheelchair that I got when I was first injured and lasted about 6 weeks. So could you imagine being in somewhere in Africa where you don't really have a lot of access to maintenance facilities or good clinical care, how long that chair would last. And that's part of the problem. Since we're talking about invention, there's really been about 3 of us who've driven this. This is Ralph Hotchkiss. Actually, he's retired now, but he was a professor at San Francisco State University, and he came up with this whirlwind wheelchair. And his approach was to go into low-income countries or less resource environments and to teach local people with disabilities to build wheelchairs. And this is largely made out of low-strength steel, mostly electrical conduit type material, and bicycle parts. The front casters are somewhat unique. They're actually recycled tires. In most low-income countries, you see people getting their car tires retreaded, and so there's an opportunity there to use those. And I actually developed the molds for him, because of our machining capabilities. And then the next person is David Constantine. David was injured in the 1990s. He's from Great Britain. He came up with his own chair, the motivation chair, that has somewhat more adjustability than what Ralph's chair does. And David's come up with an entirely different model. His model is he has the chairs made in Vietnam and China, and then different groups like the Latter-day Saints or other groups then buy the chairs and distribute them. And hopefully I'll get into a little bit of what are the pluses and minuses of that. And then I have an entirely different model, which is, and that's the chair one of the chairs that we designed for less resource countries. And that is to go into countries, work with their governments to actually set up a factory and then manufacture the chairs locally. So this is actually me literally teaching some people to weld and use jigs in Kanpur, India, where we had set up we piggybacked on a factory that the United States had helped set up to make artificial limbs of India Manufacturing Company with the support of the Indian government. So it was a joint USAID provided some initial startup, and then Indian government's taken over, and they made wooden limbs, which was, to me, rather surprising when I first went there in the mid-1990s to see wooden limbs being made. We actually got them in touch with the WHO, and now they make aluminum pylon limbs and fiberglass. But they weren't making wheelchairs, and we got them into making wheelchairs. And then we've since then brought this to Colombia and Mexico and some countries in Africa as well. And the idea there is that you make it a business model, but you want the national health system of the country to basically reimburse them. So we got, in India, for most of the countries, we get between $100 and $150 as the budget for making the chairs. The other problem is resulting in improving quality, which is a problem in the United States as well as less resource countries. There are ISO standards, International Standards Organization standards in the United States. ANSI is the governing body, the American National Standards Institute. FDA regulates wheelchairs in the United States. And unfortunately, though, almost none of the wheelchairs comply. There's less than 20% compliance with the standards, even though they're FDA approved and provided by Medicare. So one of the problems is you have to train, then get people that are making wheelchairs and designing wheelchairs to use better engineering practices, and you also have to get consumers and clinicians educated to be able to look at least for common failures. So we actually have a great NIH-funded multi-site trial going on right now to provide wheelchair users wheelchair skills training and wheelchair maintenance training so they can be at the front line in helping themselves. And there are stupid failures if you're an engineer. We're looking at stresses, fractures in high stress areas where there's a stress riser, and just kind of a bad idea. This is threads on the caster fork breaking. This is an invention of mine to help solve that problem. It's called the Glide. If you look up the patent, we gave it the catchy name, oblique angle suspension caster fork. The manufacturer calls it the Glide, but it adds a suspension element, somewhat like on a motorcycle, or to help absorb those shocks. But it actually had the other added benefit of not only increasing durability, but reducing the whole body vibration, so which would cause spasticity and could cause neck pain and headaches as well. Service delivery is also essential problem. Even in the United States, Medicare requires this credential called the Assistive Technology Professional for the provision of what are called rehab chairs. You don't really need to know that, but Medicare has different K codes for products, and there are certain K codes that you have to have this ATP credential, which was something I worked on in the late 80s and early 90s with RESNA, the Rehab Engineering Assistive Technology Society of North America. Even so, there's about 6,000 ATPs in the United States, and like most problems in healthcare, they're all clustered around the major population center. So if you don't live in a major population center, you have to get to one to get a wheelchair prescribed to you, or at least a good quality wheelchair. So what happens? You get a poor quality wheelchair because you have to drive 300 miles to get a good wheelchair, so you get a poor quality wheelchair. The other problem is that we're trying to get into the PT schools and the OT schools to say, how do you do a better job understanding that this is an important part of what you do? So we did a couple of inventions. This is actually started out as my doctoral work. So I'm not terribly young. So back in 1986, I think I started. 89, we finished this out. I wanted to bring this up because it became a product in 2001, so your inventions don't necessarily become. And it was the best new product of the year in 2002. So I like to tell people it's like singing in honky tonks for 20 years, and then you become a new artist of the year. And so not all your inventions come to market right away. But now it's used in every research lab in the world, basically, and almost every large clinic in the world, to assess how the forces are applied to the hand rim. So it tells you how to push the chair more efficiently, how to reduce strain on the shoulders, the wrist, and the elbow. And it actually resulted in, I'll tell you, one of the patents on my chair, the natural fit hand rim, which is this ergonomic hand rim. So when the little 7/8 inch diameter tubing that are on most chairs, we use this device to study how would you change the shape and the size of the hand rim in order to reduce the stress on the upper extremities. And then that would reduce the risk of developing these debilitating injuries, which many people equate as requiring a new disability that's even more severe. And this became a product almost 10 years ago now. And there's been a couple of strings of patents along that line. The other problem that comes about is if you really want to make wheelchairs better and you want to get people to understand how they're used, you have to know how they're used. So that was another invention that my team worked on. It's basically a simple data logger, and it goes on the spokes, and you can forget about it. It collects data up to 3 months. And this is the initial version, which had some really interesting impact that we weren't necessarily expecting at the time. So most power wheelchairs come with these big, large lead-acid batteries that weigh about 150 pounds, retail for about $800, and have to be replaced every year. And they were designed because people thought that power wheelchair users would go about 20 miles a day. And when we recorded it, it turns out they go about a mile a day. One standard deviation is about 3 miles a day. 2 standard deviations is about 5 miles a day, which means you could go with smaller batteries. You could actually go to, we found out that we work with Yamaha to get nickel cadmium batteries, turned out to work out, the nickel metal hydride, now we see lithium polymer batteries. And so it makes the chair smaller, lighter, and batteries easier to change. And then the World Health Organization got involved through USAID support and is now working on a series of training manuals to train people on how to do wheelchair provision. Now this is really just manual wheelchairs, very basic, but like I said back earlier, that the model that like David Constantine is using is that you want to get Latter-day Saints and Rotary and people like that and retirees that might have healthcare experience or might have engineering experience to be able to provide good quality wheelchairs when they volunteer in less resource countries. So we're actually now working on an online badge system that you might be familiar with where you can take these trainings and earn badges. And then lastly, it's about empowering people with disabilities as well. One of the basic things that's really helping us drive now is the UN Convention on Human Rights for People with Disability, which the U.S. is not yet a signatory to, but hopefully will be soon, and also providing career opportunities for people with disabilities. And that middle picture is actually a program we run to introduce wounded warriors to engineering professions through like a 12 or 16-week program. So this is kind of my take-home message for you, and leave you with our Invention ambassadors.